So the problem that we've got is we've got sine rule, we've got the cosine rule, and we've also got the area rule. So we're going to be finding over the next few lessons how to actually understand which one we need to be using in each case. Now, when it comes to sine rule, I want us to be thinking, if you get something that looks like this, so corresponding side to angle with corresponding side and angle, we can actually use the sine rule. And it will actually make sense as you actually practice these questions. So for each of these questions, okay, we'll use Pythagoras or SOHCAHTOA. So pause it and just put an S or a P. So for the first one is Pythagoras, okay, because of one length. SOHCAHTOA, SOHCAHTOA again, SOHCAHTOA, Pythagoras, and the last one here is sine rule. Now, why can I not use SOHCAHTOA? Well, actually, I've not got a 90-degree angle. This is 92. So you can actually see I'm doing this here. So the moment that I get to do that is I need to make sure that I use a sine rule. Sorry. So it's really, really important that you understand that is that if you've got a capital A, the opposite side will be a small a for it, okay? And that's how we indicate angles and sides. Same for the B and same for C. So let's actually use the sine rule. So step one is always label the angles and sides, okay? So you've got A, B, and C. That's why they've labelled the A, B, and C for us. The opposite pair is when you have A and B, or B and C, and so on. Oh, sorry. A and A, B and B, and C and C. So we use the sine rule. Now, whenever you're trying to find a missing length, you're going to be using it in this way, because it simply will make it easier when you're trying to find the unknown. And whenever you're trying to find a missing angle, you're going to be using this one, because again, it's just easier when actually trying to change the subject of the formula. So, can we use the sine rule or no? So I've got angle with corresponding side, angle with corresponding side. So yes, we can. Angle with corresponding side, angle with corresponding side. Yes, again. Angle with corresponding side, but I've not got another angle with a corresponding side. So for this one, I wouldn't be able to actually use it. So, can we use the sine rule again? So pause it and try these questions. So, yes, we can. Nothing else to match, so no, we cannot. Yes, we can. Yes, we can again. Pythagoras down there. We're going to... And again, we cannot. So, example here, again, we're going to be using the sine rule for us. So we're trying to find A. So first thing we do is make sure that you do these lines, because then that tells you the pairs. So am I trying to find the length? I'm trying to find the angle, but you're trying to find the length. So it's A of a sin A equals to B of a sin B. So what is A? Well, A of a sin what? Sin 55, because it's corresponding, and 12 of a sin 72. Somehow I want to get rid of that sin 55. So what's the opposite of dividing by sin 55? Well, the opposite of dividing by sin 55 is timesing both sides by sin 55. So you're left with A equals 12 of a sin 72 times sin 55. Then all you've got to do is type this in your calculator, and that gives you 10.3 if you do it correctly. So pause the video and try these questions for us. So again, you're looking for the pairs. Now for this question here in the bottom, I've not got a corresponding angle, but you know that in a triangle you've got 180 degrees, so you can use that to work it out. And for here, same again, angles in a triangle add up to 180. So 180, take 57 and take 80. So your answers should be 7.93, 8.59, 23.50, I imagine, and 15.90. It should be two different places, so apologies. What if you actually wanted to use the sine rule to work out a missing angle this time? Well, same again. You can actually see you've got this. But now you're going to do sin C of a C equals to sin B of a B. It doesn't matter if you're sin A of A again. So sin C is what we're trying to find. Of a C, which is corresponding, equals to sin 29 of a 19.2. Well, I want to get rid of that 17.1, so I'm going to times by 17.1. So you're left with sin C equals to sin 29 of a 17.1 times, of a 19.2 times 17.1. Now, if you do work this out in your calculator, you've worked out sin C. The question's actually after angle C. So remember, you need to make sure that you do the same function what you do with SOHCAHTOA with angles, the sin minus 1. So really, if you want to be lazy, you can do C equals sin minus 1 of the whole function. And type in your calculator. And if you've done it correctly, you should get 25.6. All right, let's try once more. So again, let's do sin B of a B equals to sin C of a C. Well, so sin B of a 28 equals to sin 92 over 41. I want to times by 28, times by 28. Sin B equals to sin 92 over 41 times 28. But I don't want to find just sin B, I want to find B. So B equals sin minus 1 of the whole function. And then if you've done it right,